All right, for today's problems, we're going to be working on geometry. Let's take a look at the problem here and see if we can't change this into a quadratic equation so that we can solve it. So we have the information, the length of a hallway exceeds its width by 16 feet. If the area is 105 square feet, what are the dimensions of the hallway? So I guess we should think about what the shape of a hallway would be. I think that we could assume that most hallways are rectangles. All right, and so let's go back and read it again and start to think about the information we're provided. So we read it again and it says the length of the hallway exceeds its width by 16 feet. So the subject of the sentence is the length of the hallway. And what does the length of the hallway do? It exceeds, so it's greater than the width by 16 feet. So it's the width plus 16 feet because it exceeds the width. Okay, pardon me. Okay, we also know that the area of this entire hallway is 105 square feet. So we know the area is 105. Okay, what are the dimensions of the hallway? So we need to find the length and the width. So when I go back to this problem, when I read that first sentence, I know some information about the length, but I don't really know anything about the width. So I say that we could let W equal the width, so we can define that information. Okay, so if the width is W and the length exceeds the width by 16 feet, then the length could be written as W plus 16. And we want that so that our length and our width are in the same variable. All right, so we could also say that the area is equal to the width times the length. So I think we have enough information here to go to our equation. We know that the total area is 105 and the length times the width is W times W plus 16. So we'll come over here and go W times W plus 16 is equal to 105. And we're going to multiply that. W squared plus 16W equals 105. And now what we're going to do is we're going to decide whether we're going to use the square root property. Well, we're not going to square root property because we have a B term. Quadratic formula, factor, or complete the square. I think it's set up for complete the square and it wouldn't take too long to do that. But you choose what you want to do because factoring is also pretty quick and the quadratic formula will work. Okay, so you take the time to do that. And then we'll come back in a minute and see how you did. Okay, so I went ahead and chose factoring. And I have the answers that the width is equal to negative 21 or it's equal to 5. Well, we have to discard negative 21 because we can't have a negative 21 feet long. And so now we know that the width is equal to 5. Let's go back now and answer the questions. It says, what are the dimensions of the hallway? Well, if the width is 5 and the length is the width plus 16, then it'd be 5 plus 16, which is 21. So the length would be 21. So the width 5 feet, the length 21 feet. And there you have it. Okay, next question. All right, this next question here, we have a triangle shape that we've been provided with. Let's take a look at the problem. It says a sidewalk that's 85 meters long joins building A to building B. However, people prefer to walk directly between A and B, a distance of 65 meters. How long is each piece of existing sidewalk? Well, I do know that this information is given to me. I'm also seeing that I have a right triangle here. So I'm going to put that information in there and I'm going to start thinking about what I'm going to do. Okay, so we are supposed to find how long is each piece of existing sidewalk. So I'm looking at this right triangle here And this is building A and this is building B. I'm going to call this point here where the sidewalk turns at a 90-degree angle side C. I'm going to go ahead and label this like I would a right triangle. So if this is angle A, then this would be side A, angle B, side B, angle C, side C. Okay, and I know the length of C. What I need to do is find the length of A and B. So I guess what I'll do here is determine which one I want to let be my unknown. So I think I'll let A be my unknown. Okay, and so we're going to let A equal the long leg of our picture here. Okay, so how am I going to determine what B is if this is A? Well, here's what I go. If I go back to the problem, it says the sidewalk's 85 meters long. So from here, from point A to point B, it's 85 meters long. So if this is A units long, how am I going to determine what the length of B is? Well, I know that side A plus side B has a length of 85. So if I were to actually solve it for B by subtracting A, I could see that B is equal to 85 minus A. So that would be a good measurement for the length of sidewalk B, which would be really helpful, because what I want to do if I'm writing a quadratic is I need to keep my variables the same. Since I've chosen A, we've got to write it all in A. Now I'm looking for the lengths of a right triangle. So I probably, or the sides of a right triangle, excuse me, should use the quadratic, not the quadratic, the Pythagorean theorem. And that's B squared equals C squared. So A squared plus B squared equals C squared. We have enough information now to plug this in. So if A squared plus, and we've decided that B is going to be replaced with 85 minus A quantity squared equals C, which we do know, which is 65 squared. Okay, so we're going to go ahead and solve that and see what we come up with. Excuse me. Okay, so we get A squared plus, and you multiply that out, 85 minus A times itself equals 65 squared, which is 4225. We're going to have to do a little more math here. A squared plus 7225. And then I'm going to go ahead and multiply my outer and inners and add them together. That's negative 170A. And then negative A times negative A is positive A squared equals 4225. And then we'll put it in standard form. So combining my A squareds, 2A squared minus 170A, bringing my 4225 over, plus 3000 equals 0. I'm looking at this thinking I could simplify this by dividing everything by 2. So we're going to say this is A squared minus 85A, that's 3000, excuse me, plus 1500 equals 0. And now we decide, do we want to use the quadratic formula, factor? Certainly don't want to complete the square because I don't want to cut 85 in half and square it. So I think I'll go ahead and use the quadratic formula in this situation. So A is equal to the opposite of negative 85 plus or minus the square root of negative 85 squared, and it's 4 times 1 times 1500 all over 2 times 1, which I'm just not going to write that out. So I get A is equal to, if I plug that into the calculator, magic, 85 plus or minus. This comes out to a perfect square. It's 35 squared, so we're going to call it 35 all over 2. And then we're, of course, going to do the answers. We end up with either A equals 60 or A equals 25. Okay. So let's go back and determine what each leg is. So if A is 60, we've determined that it's 60, and B is 85 minus 60, then B equals 25. Okay, and if we were to split it, change it. And if A was 25, well, then B would be 60. So I guess it really doesn't matter. The pieces of the sidewalk were 25 meters, excuse me, and 60 meters long. Okay, last problem. Here we go. Now with this problem, we don't have a lot of information, you'll notice. We're just asked to find the dimensions of a rectangle whose area is 240 square feet and has a perimeter of 92 linear feet. Excuse me. So let's go ahead and look at a rectangle here and see what we can determine. We know it has an area of 240, but we don't know what the width or the length is. We don't know anything about that information. We also know that the perimeter is 92 linear feet. So this information must be useful to help us find our width and our length. So remember that your area is equal to length times width, and your perimeter is 2 lengths plus 2 widths. So let's go ahead and define our unknown. I'm going to go ahead and say that W is equal to my width. And so what I'm going to do is I'm going to write the length in terms of W so that we have one variable W instead of two different variables, which makes this very difficult to solve. So a couple things I could do. I could figure out the length of this rectangle here by solving perimeter for length, or I could solve the area formula for length. So we're going to just derive a formula. I think I'll go ahead and use perimeter in this situation. So what I'm going to do is I'm going to find length by solving the perimeter problem. Perimeter is equal to 2 lengths plus 2 widths. So to solve that, I'm going to go ahead and subtract 2W. So we get P minus 2W equals 2L. And you know what? Let me go back and think through that a little better. I know what the perimeter equals, so how about I actually use that information? The perimeter actually equals 92. So I'm going to go ahead and plug that information in. So here we go, 92. That's your perimeter. I'm going to go back. Okay, back it up. Sorry. I'll go back and edit this at the end. Okay, so we're going to go back and use our perimeter to help us determine what the length is in terms of width. So our perimeter is 92, and 92 is equal to 2 lengths plus 2 widths. So we're going to solve for L, so we can figure out how to solve this equation. We're going to subtract 2W. We get 92 minus, that's a 2, minus 2W equals 2L. And we're going to divide everything by 2. And we get 46 minus W equals length. Okay, so now we know that the length is the same thing as 46 minus the width. So I can come up here and change this to 46 minus the width. Okay, so the width is our unknown, and the length is 46 minus the width. So now what we're going to do is we're going to come over here and create an equation. So what I'm going to do is I'm going to plug it into the area formula. So area is 240, and 240 is going to be equal to the width times the length in terms of width, so that we have a quadratic equation here. So we'll multiply. So 240 equals 46W minus W squared. And then we'll go ahead and decide how we're going to solve that. So I think I'll go with W squared minus 46W plus 240 equals 0. I just moved both of those to the other side of the equation. And I think I can factor that pretty quickly. You could use a quadratic formula. You can use what you want. So you solve that, and we'll pause it, and then we'll come back and see how you did. Okay, and so I chose to factor, and I have the answers. The width is either 40 or it is 6. So if I come back up here and I'm just trying to find the dimensions of this rectangle, if the width is 40, then the length would be 46 minus 40, and the length would be 6. So I could say that the width is it's 40, is it in feet? And then the length would be 6 feet, or it could be vice versa, of course. If the width is 6 feet, then the length would be 40 feet, and I don't think that matters in a rectangle, which is which in this situation. Let's just make sure it makes sense. We know that 40 by 6 equals 240, which is the area, and then 2 times 40 plus 2 times 6 should equal the perimeter of 92, and that's 80 plus 12, and so that's also correct. So in this case, we have found either answer. It doesn't matter which you choose to be your width and which you choose to be your length. And there you have it. Okay, so that is your lesson on geometry for today. Thank you. Have a good one.